Hello students, welcome to the next module of the chapter surface tension, and in this module we are going to start a new type of MCQs, and these MCQs are based on the concept of work done. Now, before we actually start with the concept of work done, we should revise a formula of work done, and that is nothing but dW is equal to T into dA, where dA is the change in area, T is the surface tension, and dW is the work done. So let us start with the new type of MCQs. The very first MCQ says that if the surface area of a liquid surface is increased by 50%, then its surface tension will. And the four options are increases by 50%, decreases, does not change, or it gets doubled. Let us again read the question, class. If the surface area of the liquid surface is increased by 50%, then its surface tension will. Class, we know that surface tension is independent of area. So even if you increase the area by 50%, 70%, 100%, or you decrease the area, it does not affect the surface tension of the liquid. So in this question, the answer would be the surface tension value does not change as it is independent of area. Now, let us move to the second question, and that is if the surface tension of a liquid is 5 newtons per meter, then the surface energy of the liquid film on a ring of area 0.15 meter square is, and the four options are 1.5 joules, 3 joules, 2.25 joules, and 0.75 joules. Let us again read the question. They are saying us if the surface tension of a liquid is 5 newtons per meter, then the surface energy of the liquid film on a ring of area 0.5 meter square is. Now class, we know that dW is equal to T into dA. But when we talk about a ring, the formula gets multiplied by 2. Why? Because of two free surfaces, class. If we talk about a ring has two free surfaces, one on the front side and one on the back side. So I say that since ring has two free surfaces, the formula gets multiplied by 2. Now we know that the tension is given to us as 5, and dA is the change of area, which is nothing but 0.15 meter square into 2. So I get dW is equal to 1.5 joules, and that is nothing but option number A. Now, let's move to the next question, and in this question, they are telling us a spherical mercury drop is broken into 1000 droplets. If you remember, class, we have solved these kind of questions earlier. There is one single drop, you allow the drop to fall down, and when the drop falls down, it gets split into number of droplets. So in this question, I have one drop which is falling down and getting converted into 1000 droplets, all of the same size. The physical quantity that does not change is surface energy, radius, surface area, or density. Now class, if you try to recall, or if you apply some logic, I can say, when a drop falls down and it gets split into many number of droplets, it is quite obvious that the many number of droplets will obviously be small in size comparatively. So I can say that radius is a quantity which is going to get changed definitely. So radius cannot be the answer. Now if you look at the formula, dW is equal to T into dA. Now when one drop falls down and gets converted into many number of droplets, its surface area increases. So if the surface area is increases, that means it is changing, and if it is changing, I can say that dA is the quantity which is surely going to get changed, and hence C cannot be the answer. Now, if you look at the formula, dW is equal to T into dA. Since dA is changing, dW has to change. So, surface energy also cannot be the answer, and this gives us the conclusion that final answer has to be D. That is, density is the quantity that will not change, because even if the drop falls down, the material or the matter remains same, and hence density is the quantity which will not change. So, final answer would be D. That is, density is a quantity which does not change. Now, moving to the final question, I say that 1000 small water droplets of equal size combine to form a big drop. Now class, in the previous question, one drop was getting fall down. One drop was falling down and getting converted into many droplets. So I say that its surface area increases. this time many number of droplets are combining to form one big drop. So I say that its surface area has to decrease. The question says that the ratio of the final surface energy to the initial surface energy of the water droplet is, and the four options given to us are 1 is to 1000, 10 is to 1, 1 is to 10 and 1000 is to 1. Class, if you reread the question, let us read the second line. The second line says that the ratio of the final surface energy. Now class, they want final surface energy in the numerator, and I know that when many number of droplets combine and make one drop, its surface area decreases. So final energy has to be less than the initial energy. So I say that D and B cannot be the answer, as in the numerator they have a bigger number, right? So I have now only option A and option C. Let's solve. We know that r cube is equal to small n cube into small r cube, where capital R is the radius of the big drop and small r is the radius of the small drop, and small n is the total number of droplets. So I say that r is equal to n raised to 1 by 3 into small r. Now r is equal to, value of small n is given to me as 1000. So if I solve it further, I get capital R is equal to 10 times small r. Now class, I know that dW is equal to T into dA. So if I talk about energy initially, that is when I had too many number of droplets, it becomes 1000 into T into 4 pi r square. And when the droplet combines and in one drop, I have T into 4 pi, radius becomes 10r, so radius square becomes 10r square. Now they want me to find out the ratio of final to the initial, that is E2 is to E1, and if I substitute the values and if I cancel out the common figures, I get E2 upon E1 as 100 by 1000, which is nothing but 1 by 10. So my final answer happens to be option C. I hope you have understood the module class. See you in the next module. Thank you.
I have no information about them.